This is section 8.5, multiplying and dividing radical expressions. First, for multiplication, we're going to get a lot of practice with multiplication as we learn the division problems. So we're not working too many individual multiplication problems. Let's say we want to multiply the square root of 2 times the square root of 18 minus the square root of 3. This should look like a distribution to you. If you just imagine the square roots being gone and we have some variables in here or whatever, it looks like a distribution, and that's exactly what it is. So I'm going to multiply these two and then these two. Now I want to remind you that we have a property that says if they are the same kind of root, if your index is the same, then you can multiply underneath the radicals. So this is the same thing as the square root of, because these are all square roots, 2 times 18 is 36. Minus the square root of 2 times 3, which is 6. Okay, now we need to simplify this as much as possible. The square root of 36 is 6. Okay, minus 6, we would simplify this radical if we could, but 6 is 2 times 3, so we don't have any pairs in there, so the square root of 6 remains. Now, like I've said many times, these smaller calculators can handle smaller things. So if I want to enter the square root of 2 times the square root of 18 minus the square root of 3. Oh, that's wrong. The square root of 3. Okay, close parentheses, and you do get negative square root of 6 plus 6. I'm not sure why it enters things in this order, but you know enough to see that this is the same thing as 6 minus the square root of 6. Okay, so that would be your entire answer. We are not allowed to combine those. Okay, so let's look at the square root of 3 plus 2 times the square root of 6 minus 5. This should look like a distribution or FOIL problem, and that's exactly what it is. We take the square root of 3 and we distribute, and then we're going to come back and distribute the 2, and we will combine like terms where we are able to. Okay, so if I have the square root of 3 times the square root of 6, that's going to be the square root of 18, multiplying underneath the radicals. The square root of 3 times the negative 5 would be minus 5 times the square root of 3. Okay, now let's do the 2 times the square root of 6. It's going to be plus 2 square root of 6. 2 times negative 5 would be minus 10. Now we need to see if any of these simplify. The square root of 18 does. I'm pulling out the sheet we've used several times now. We've done the square root of 18. You can pull a 3 out and a 2 is stuck on the inside. So this is the same thing as 3 times the square root of 2 minus 3 is prime, so that doesn't simplify. We just talked about how the square root of 6 doesn't simplify. And then minus 10. Now I look at this, do I have any of the same radicals? No. This one doesn't even have a radical. There's none of these I can combine. This whole thing is my answer. Okay, so let's look at 4 times the square root of x plus 3 all squared. Okay, now this is a perfect square trinomial. We have this case, and you can use this formula. It works absolutely perfectly well. But a lot of people get really confused when there's a radical in it, okay? So what I'm going to suggest that you do here, if you're comfortable with that last formula, by all means use it. It's going to be the quickest way. But if you don't use that, or if you're not comfortable using that, you should rewrite this as 4 times the square root of x plus 3 times 4 times the square root of x plus 3, and we will distribute the same way we did up here, okay? So 4 square root of x times 4 square root of x, this is going to be 16 because 4 times 4. And I'll go ahead and write out this step. It's the square root of x squared, which you should recognize simplifies. Okay? Plus 4 square root x times 3 is going to be 12 square root x Now distribute the 3. You're going to get 12 square root x again. And then 3 times 3, which is 9. Okay, the square root of x squared is x, so that's 16x. I have the same radicals here, so I can add the numbers in front to get 24 square root of x plus 9. Okay, let's look at this in terms of the formula, and you can see that it's going to be true. This says you square your first term. If I square the 4, I get the 16. When you square a square root, you get the radicand, you get the thing underneath. So when we squared that, we got square root of x squared, which just gave me what's underneath. That's going to be an important concept in a later section. Okay, and then it says you multiply these two things together, which gives you 12 square root of x, and then you double it, which does give you 24 square root of x, plus your last thing squared, which is 9. Okay, we are going to be squaring things like this a lot in the next section. Okay, another thing to recognize, and this is going to be important later in this section, is that when we squared this, we did not get rid of the square root entirely. There's still one in there. Okay, so this is our answer, and we'll be coming back to this concept. Okay, so let's talk about dividing with radicals. We know from when we first started simplifying radicals, one of our requirements was that we're not allowed to keep a radical in the denominator. And we said that we will deal with that a lot later, and we're here. Okay, now if we've dealt with ones that were perfect squares in the bottom, so we could easily get rid of that root. We have worked with some where if you put it under the radical, if you create the fraction, then the fraction reduces and you have a perfect square in the bottom. That's not going to work here at all. Okay, now what we're doing here is often called rationalizing the denominator. Radicals that don't simplify away completely are irrational numbers, meaning that it's a decimal that never ends and never repeats. And so we want to get that out of the denominator. Now there are two main cases. There is the case where you have a simple radical underneath, and then you have the case where you have a more complicated with an addition or a subtraction in the denominator. So that's a separate case. But for right here, what we want to do when you have a simple radical in the bottom is you want to multiply the top and bottom by the same value. We're always allowed to do that as long as we're not multiplying top and bottom by a 0. What you want to do is you want to multiply top and bottom by whatever your denominator is. And then we will simplify as possible. Okay, I have the square root of 3 times the square root of 2, which is equivalent to the square root of 6. And we know that does not simplify in any way. I have the square root of 2 times the square root of 2. Again, I'm squaring a square root. That should give you what's underneath. This is going to be over 2. But if you want to see that step written out, it would be the square root of 4, because we'd have 2 times 2. And then the square root of 4 is 2. Now we would simplify this radical if we could. We would reduce the fraction if we could. But that doesn't work at all. So that will be our answer. I believe if you enter this in your calculator as a fraction, it will rationalize for you, and it does. But remember, this only does small values and it only does square roots. It doesn't do any other kind of root. So you can't depend on this as your method of solving. Okay. Okay, so let's look at some where our radical in the bottom will simplify. The square root of 24 will simplify. And notice I have the same problem here and here, method 1, method 2. You get to decide what you think is the easier way to do it. Okay? You can simplify the radical first and then rationalize, or you can rationalize first and then simplify. Okay? It's going to be completely up to you. So I'm going to work it first where we just multiply the denominator by itself, the top and bottom by whatever that is. We are allowed to do that. So this would be the same thing as negative 5 times the square root of 24. And this is going to be over. Remember, when you're multiplying a radical by itself, you get what's the radicand, you get what's underneath. So that's just 24. Okay, so let's see if the square root of 24 will simplify. I've told you that it does, but all right, look right here in this one. If I cover up that 48, I have 2 times the square root of 6 because I have a pair of 2's and then I have a 2 and a 3 left over, so they get multiplied back. So that's 2 square root of 6. So this is equivalent to negative 5 times 2 square root of 6 over 24. Okay, so this is negative 10 times the square root of 6 over 24. Now we reduce the 10 and the 24. They're both divisible by a 2. If I divide this by 2, I get a negative 5. Divide this by 2, and I get a 12. We are not allowed to reduce this 6 and this 12 because this is not a 6. This is the square root of 6. This is going to be 2 point something ugly, and it's not going to reduce. So our overall answer is negative 5 times the square root of 6 over 12. So that's one method where you rationalize first and then simplify. Okay, let's simplify first and then rationalize. We just figured out that the square root of 24 is 2 times the square root of 6. So I'm simplifying like that. Now I'm going to multiply top and bottom by the square root of 6. Okay, so this gives me negative 5 times the square root of 6 over 2 times, at square root of 6 times square root of 6, we're multiplying it by itself, so that means we get 6, which gives me negative 5 times the square root of 6 over 12. And that's the same answer we got here. For a lot of people, this is easier to understand. This is usually easier to complete. So it's kind of a trade-off, and it is completely up to you. They both work.